Hello, friend. Welcome to Pets for Sleep. Whether you have been here before or you are finding this quiet little corner for the first time tonight, this is a place to slow down, learn something gentle about the animals we share our homes with, and let the day soften a little as we go. Maybe your cat has a perfectly good bed. It might have thick padding, soft fleece, raised sides, and a warm spot beside the window. There may be a blanket folded neatly on the couch, a pillow at the end of your bed, or an entire mattress available whenever your cat feels like climbing onto it. And still, you walk into the room and find your cat curled into a sweatshirt you left there 20 minutes ago. Sometimes it is a hoodie on the bed. Sometimes it is yesterday's jeans on the floor. It might be a t-shirt draped over the back of a chair, pajamas beside the pillow, or a laundry basket filled with clothes you have not put away yet. The cat turns around once or twice, tucks its paws underneath its chest, closes its eyes, and settles in as though this was the best sleeping place in the house all along. Not every cat does this, and even cats that enjoy sleeping on clothes may choose completely different places at other times. But for cats that do return to clothing again and again, the choice can feel surprisingly specific. Domestic cats spend a large part of each day asleep or quietly resting. A common estimate is somewhere around 12 to 16 hours during a 24-hour day, although kittens, older cats, very active cats, and individual adults can fall outside that range. That means a cat may choose a resting place many times during a single day. Where it settles is not just a decision made once at bedtime. It can move from a sunny windowsill in the morning to the back of the couch in the afternoon, to your bed in the evening, and then onto a small pile of clothes sometime during the night. If you enjoy these quiet journeys, you are welcome to subscribe. And if it feels natural, to leave a comment sharing where you are listening from tonight. It helps other people find this calm corner for animal science, one sleepy listener at a time. When a cat repeatedly chooses your clothing, the easiest explanation is also the most personal one. Your clothes smell like you. And that is very likely part of the story. A shirt that has spent several hours against your skin does not smell the same as a shirt that has been sitting untouched in a drawer. Even when the difference seems faint to you, the fabric has been in contact with your skin, hair, sweat, natural oils, soap, shampoo, and whatever parts of the house or outside world you moved through while wearing it. For a cat, which depends much more heavily on smell than a human does, those differences can matter. But scent alone does not explain everything. The same hoodie that carries your odor is also soft. If it is folded or crumpled, it can form a shallow hollow around the cat's body. Several layers of fabric can trap small pockets of air and slow the loss of body heat. If you recently wore the garment, it may still hold a little warmth. If you leave it in the same chair each evening, the location itself may become familiar. And if your cat has slept there comfortably several times before, that history can make the place even more attractive the next time it appears. So one ordinary piece of clothing can combine several things cats often value at once. It can be familiar. It can carry recognizable odor. It can be soft beneath the chest and hips. It can hold warmth better than a bare floor. It can create edges that fit around a curled body. And it can appear in a place the cat already associates with quiet rest. That makes the question more interesting than simply asking whether your cat misses you. A cat sleeping on your clothes may be responding to your relationship, but also to chemistry, temperature, texture, memory, and the physical shape of the resting place itself. To understand which of those matters most, it helps to begin with the part we cannot see. Before your cat ever lies down on that worn shirt, the fabric has already collected a surprisingly detailed chemical record of you. During a few ordinary hours of wear, fabric begins collecting material from almost every surface it touches. Some of that material comes directly from your skin. Some arrives through sweat. Other traces come from hair, soap, deodorant, furniture, food, outdoor air, and the rooms you have moved through. Together, these layers create what we casually call your scent. Body odor itself is far more complicated than a single chemical. Human skin contains millions of glands, and several different kinds contribute to the mixture that ends up on clothing. Sebaceous glands produce sebum, an oily substance that helps coat the skin and hair. These glands are especially common on areas such as the face, scalp, chest, and upper back. Sebum contains fatty substances that can spread onto collars, sleeves, pillowcases, hats, and anything else pressed against the body. Unlike water, these oils do not simply disappear as soon as the fabric dries. They can remain caught among textile fibers until washing removes much of them. Sweat adds a different layer. Eccrine sweat glands occur across most of the human body and are especially dense on the palms, soles, and forehead. Their main job is cooling. When the body becomes warm, these glands release a watery fluid onto the skin. As that water evaporates, it carries heat away. Fresh eccrine sweat is mostly water, with dissolved salts and other small compounds, so it usually has much less odor than people expect. A second type of sweat gland, called an apocrine gland, is concentrated in places such as the armpits. These glands release a thicker fluid containing proteins and fats. The stronger smells associated with human body odor often appear after bacteria living naturally on the skin begin breaking those materials apart. During that process, the microbes produce smaller volatile molecules. Volatile simply means that a substance can enter the air fairly easily. Once airborne, those molecules can reach a nose. That is why a shirt worn through a warm afternoon may develop a recognizable smell, even though the sweat that first entered the fabric had very little scent of its own. The bacteria on your skin help create part of the final odor profile. Hair adds more material. Tiny skin flakes are shed continuously. Shampoo residue may remain on strands near the collar. Deodorant can rub directly into the fabric under the arms. A scented lotion or perfume can add compounds strong enough for a human to notice from several feet away. Even products you no longer consciously smell may still leave molecules behind. The clothing itself contributes too. A clean shirt can carry traces of laundry detergent, fabric softener, a dryer sheet, or whatever other fabric shared the wash. After you put it on, those laundry odors begin mixing with compounds from your body. Then the outside world starts adding another layer. Sit on a fabric couch and the shirt presses against fibers carrying their own odors. Cook dinner and tiny airborne molecules from garlic, oil, coffee, or toasted bread can settle onto clothing. Walk outdoors and the garment may encounter soil particles, pollen, vehicle exhaust, wood smoke, rain, or the smell of another animal you touched along the way. Most of these traces are present in amounts too small for us to think about. Textiles are very good at holding on to some of them. Cotton, polyester, wool, and other fabrics have different fiber structures and chemical properties, so they do not all retain odor compounds in exactly the same way. Some molecules remain near the surface. Others become trapped among threads or bind loosely to oils already present in the fabric. Scientists use the word adsorb when molecules collect on a surface. It sounds almost like absorb, but the process is slightly different. Absorption means a substance moves into another material. Adsorption means molecules stick to its surface. Both kinds of interactions can help a garment hold chemical traces after it has been removed from the body. This is why a shirt worn for several hours is chemically different from an identical shirt taken straight from a drawer. To human senses, that difference may seem faint. A cat approaching the same shirt begins with a sensory system built to examine that invisible mixture much more closely. As your cat lowers its nose toward the fabric, some of the molecules held there begin entering the air around its face. Others are picked up when the nose comes very close to the cloth. For smell to begin, chemical molecules have to reach living sensory tissue inside the nasal passages. Each breath pulls air through the nose and across a moist layer of tissue called the olfactory epithelium. Olfactory simply refers to the sense of smell. Inside this tissue are specialized nerve cells called olfactory receptor neurons. Tiny receptor proteins on these cells respond when certain odor molecules reach them. A single smell can contain many different molecules, so the brain receives a pattern of activity rather than one simple signal. Those nerve cells send information deeper into the skull toward the olfactory bulb, a brain structure involved in organizing signals coming from the nose. From there, the information reaches other parts of the brain involved in memory, behavior, and responses to the environment. For a domestic cat, Felis catus, this chemical information has importance throughout everyday life. Food is an obvious example. A cat approaching a bowl can gather information before taking the first bite. The odor of unfamiliar food may produce a longer investigation. Changes in familiar food can sometimes be detected even when the meal looks nearly identical to a person watching from across the room. Smell also helps cats examine places. A doorway can carry traces from animals that passed through earlier. A blanket may contain the odor of a cat that slept there several hours ago. The edge of a sofa can hold chemical material left by repeated rubbing. An outdoor cat may encounter urine, feces, gland secretions, fur, or footprints carrying information from other animals using the same area. Some chemical cues can also carry information connected with reproduction. Animals release compounds that vary with sex, reproductive condition, and individual identity. Cats have an additional sensory structure that helps process some of these socially important chemicals. It is called the vomeronasal organ. This small paired organ sits near the roof of the mouth, behind the upper front teeth. Certain chemical compounds can reach it through openings connected with the mouth and nasal area. You may have seen a cat pause after sniffing something unusual. Raise its upper lip slightly, hold its mouth partly open, and remain still for a moment. This behavior resembles what scientists call the Flamen response. The posture can help bring chemical material toward the vomeronasal system for closer investigation. Male cats may show it while examining reproductive scents. Cats of either sex can also use this system while investigating interesting social odors. The regular nose and the vomeronasal organ handle overlapping parts of a much larger chemical world. Together, they allow a cat to gather information that human senses often leave in the background. Think about entering your bedroom after being away for an hour. You may first notice the bed, the curtains, or the shirt lying across a chair. Your attention is pulled towards shape, color, light, and movement. Your cat enters the same room, carrying a different set of priorities. The chair may still look familiar, while its surface also holds traces from whoever sat there earlier. The blanket can carry your odor, along with the cat's own scent from the previous night. A shoe near the door may bring in chemical traces from pavement, grass, another building, or an animal encountered outside. None of this requires the cat to consciously build a detailed story about every molecule it detects. Its sensory system simply gives chemical differences much more behavioral importance than humans usually give them. That helps explain why a cat may spend several seconds carefully sniffing an object that looks completely ordinary to us. A worn shirt has already gathered skin oils, microbial products, detergent residue, environmental odors, and compounds from the person who wore it. The cat's nose can begin separating useful information from that mixture. Sensitivity alone still leaves one important distinction unresolved. A cat may detect that a shirt smells human, while recognizing the particular person who wore it would require something more specific. That is where familiar human odor becomes especially interesting. Recognizing that an odor came from a human is only part of what a cat may be able to learn from it. A familiar person leaves behind a pattern the cat has encountered hundreds or thousands of times. In 2025, researchers at the Tokyo University of Agriculture in Japan tested whether domestic cats could distinguish the smell of their owner from the smell of a stranger. 30 cats took part. Their average age was close to 7 years, and the group included 11 males and 19 females. 17 owners provided familiar odor samples. 8 people who had never met the cats supplied the unfamiliar samples. The unfamiliar donor was matched to the owner by sex, which helped prevent a simple difference between male and female body odor from explaining the cat's responses. Collecting the odors required more control than simply handing researchers a worn t-shirt. Cotton swabs were rubbed behind each person's ear, under the arm, and between the first 2 toes. Each area was swabbed 5 times. Participants were also asked to avoid perfume and other strongly scented products on the collection day. They avoided bathing and strenuous exercise before the samples were taken, while food such as garlic and unusually large amounts of alcohol were restricted beforehand because they could change body odor. Pieces of the scented cotton were then placed inside small tubes. Each cat was presented with 3 choices at the same time. One tube contained the owner's odor. A second carried the odor of an unfamiliar person, while a third contained clean cotton as a blank comparison. The 3 tubes were mounted only about 3 centimeters apart on a clear plate. Their positions changed between trials, so that a cat could not simply learn that the interesting smell was always on the left or always in the center. A camera recorded what happened while the cat approached and investigated. Researchers paid particular attention to how long each odor was sniffed. That measurement may seem simple, but investigation time is widely useful in animal behavior research. A novel object or smell often receives more attention because the animal has less information about it. Something encountered repeatedly can require less examination. The cats in this experiment spent substantially longer sniffing the odor of an unfamiliar person than they spent sniffing their owner's odor. That difference suggests that the two human smells were not being treated as equivalent. Familiar odor appears to have been recognized as familiar enough that it needed less investigation. The researchers also watched which nostril the cats placed closest to each sample. When investigating unfamiliar human odor, the cats initially showed greater use of the right nostril. With repeated sniffing, their behavior shifted more toward the left. Similar left and right differences have been studied in other mammals, although exactly what the pattern means in cats remains uncertain. The clearest result was the difference in investigation time. Cats behaved as though the stranger's odor contained something newer than the owner's. That makes sense when we return to the chemistry held in a piece of clothing. Every person carries a somewhat different mixture shaped by skin secretions, resident microbes, genetics, diet, personal products, and the places they regularly occupy. Repeated life with one person gives a cat many chances to encounter that combination. A sleeve passes near its face while the person reaches down to pet it. Hands transfer odor during contact, and bedding receives the same person's chemical traces night after night. Over months or years, familiarity can build through ordinary repetition. There is still an important limit to what this experiment tells us. The cats showed evidence that they could discriminate between familiar and unfamiliar human odor. The study did not demonstrate that a cat forms a human-like thought such as, "This sweater belongs to my person." Behavioral discrimination gives us a more careful conclusion. A familiar person's chemical profile can be treated differently from the profile of someone the cat has never encountered. That makes your worn clothing more than a generally human-smelling object from the cat's point of view. It can carry an odor pattern linked through repeated experience with one particular person. Recognition, however, tells us very little by itself about the feeling produced by that smell. A familiar scent could attract attention, guide recognition, or simply require less investigation. Whether it actually makes a cat feel safer when the person is gone has been tested much more directly, and the result complicates one of the most common explanations for why cats choose our clothes. One of the most common pieces of advice for cat owners is to leave behind something that carries their scent. A worn t-shirt, pillowcase, or sweatshirt is often suggested for a cat staying home alone, visiting a boarding facility, or adjusting to a temporary separation. The reasoning sounds simple. If the cat recognizes the person's odor, perhaps that familiar smell will make the animal feel calmer. Researchers tested that idea directly in 2021 with 42 adult domestic cats. The study compared how cats behaved when their owner was physically present with how they behaved when the owner was absent, and only the owner's scent remained. To create the scent condition, owners wore a cotton object so that it collected their body odor. The cats then encountered that familiar smell during a controlled separation situation. Researchers watched for behaviors that could indicate distress or changes in comfort, including movement around the room, vocal behavior, interaction with the environment, and contact with the owner after reunion. The difference produced an important result. When the actual owner was present, the cat showed fewer behaviors associated with stress. The owner's presence had a measurable calming effect. The object carrying the owner's smell did not create the same reduction. In practical terms, the familiar odor was unable to reproduce what happened when the living person was there. That result helps separate several things that can easily become mixed together when we watch a cat at home. A cat can recognize an odor, it can choose to investigate that odor. The same odor may also be connected with a familiar person through months or years of experience. Emotional regulation goes further. For a familiar person to help reduce stress, the cat may be using much more than smell. The owner moves through the room. A familiar voice may be heard. Touch becomes possible, and the person's behavior changes in response to what the cat does. Those signals arrive together, moment by moment. A sweatshirt lying on a chair remains still. It carries chemical traces from the person, yet it cannot respond when the cat approaches, shifts position, vocalizes, or seeks contact. This distinction matters because the behavior we see at home can be easy to overread. Suppose a cat sleeps on its owner's shirt during the afternoon. That tells us the shirt was attractive enough to become a resting place. It does not tell us by itself that the cat was anxious beforehand, or that the shirt removed that anxiety. Preference and stress reduction are different outcomes. The 2021 experiment also does not mean owner scent has no value. The study tested a specific idea: whether scent alone could provide the same kind of comfort produced by the owner's presence during separation. The answer was limited. The scent object did not match the effect of the real person. A familiar smell can still help identify an object, make it less novel, connect it with repeated experience, or contribute to why one sleeping place feels different from another. That leaves plenty of room for scent to matter when a cat chooses clothing. It simply places that scent inside a larger system. The cat lives every day among repeated smells from bedding, furniture, doorways, food bowls, litter areas, people, and other animals. Some of those odors stay in place for hours. Oily residues can remain much longer on fabric or hard surfaces. A cat moving through the house, therefore, encounters a chemical environment with familiar patterns, even when the people who created some of those patterns have left the room. Your clothing becomes one piece of that environment. A worn shirt may carry a recognizable human odor, while the bed beneath it carries yesterday's feline scent, and the nearby pillow contains traces from many nights of contact. Seen this way, the attraction to clothes begins to fit into something larger than a portable version of the owner. The entire home is filled with chemical landmarks, and a cat spends its life learning which of them belong there. Those familiar patterns extend far beyond a single shirt. A bedroom alone can hold layers of odor gathered over days, weeks, and sometimes much longer. Sheets collect traces from skin, hair, sweat, laundry products, and the cat itself. Pillows receive repeated contact from the same person night after night. A favorite corner of the mattress may also carry fur, skin oils, and scent from the place where the cat usually curls up. From there, the same pattern spreads through the rest of the home. A sofa holds traces from the people who sit there. Door frames may receive repeated cheek rubs as a cat passes through. The floor near a feeding area regularly carries food odors, while the space around a litter box develops its own stable chemical background. Entryways can smell different again because shoes, coats, bags, and outdoor air all pass through the same small area. For a human, many of these differences are too faint to notice. The cat keeps encountering them. Repeated exposure makes familiar places chemically predictable. A particular chair tends to smell like the people who use it. A cat bed carries the odor of the animal that sleeps there. The blanket at the foot of the bed may contain traces from both the cat and its owner, because the two have touched it hundreds of times. Some odor molecules disappear quickly. Scientists call these volatile compounds because they enter the air easily. A light fragrance may fade over a few hours as its molecules spread through the room and are carried away by ventilation. Other chemical traces remain much longer. Skin oils and gland secretions can cling to fabric, wood, plastic, and upholstery. Small amounts may remain after the person or animal that produced them has left. This gives scent one unusual advantage over sight or sound. A person can leave the room, while chemical evidence of that person stays behind. The same is true for the cat. After rubbing its cheek along the corner of a table, some of the material transferred from its skin can remain on that surface after it has walked away. Over time, the home develops a layered history of repeated contact. That history can be disrupted surprisingly easily. Imagine bringing a suitcase home after several days away. Its fabric may carry odors from a hotel room, an airport, a car, another house, or outdoor places the cat has never visited. To the owner, the suitcase looks exactly as expected. The cat may spend several minutes sniffing seams, wheels, handles, and clothing packed inside because the chemical information is new. Visitors can create a similar change. Their shoes bring in traces from outside. Their clothing carries unfamiliar human odor. If they own animals, small amounts of dog or cat scent may arrive with them as well. New furniture also enters the house with its own chemical profile. Cardboard packaging, adhesives, wood finishes, foam, fabric treatments, and warehouse odors can all make an object smell unfamiliar before anyone has used it. Cleaning changes the scent landscape in another way. Wiping a door frame can remove some of the oily residue left by repeated rubbing. Washing a blanket reduces accumulated body odors and replaces part of them with detergent. A freshly cleaned floor may briefly smell more like the cleaning product than the people and animals that normally walk across it. None of these changes has to be dramatic for the cat to notice them. Familiarity develops from repetition. When the same odors appear in the same places day after day, the environment becomes easier to recognize. That helps explain why your clothing can fit so naturally into the home's chemical background. A worn shirt contains your odor, while the bed beneath it may already carry traces from you and the cat. The chair beside it has its own history of repeated use. Together, these overlapping cues create a location that smells deeply familiar. Your shirt is one recognizable piece inside that larger pattern. And the cat does more than move through this chemical landscape. Every cheek rubbed against a corner, every body pressed against furniture, and every return to the same sleeping place adds fresh material to the home again. A cat moving through a familiar room does more than detect the chemical traces already waiting there. It also leaves new ones behind. You can see this happen when a cat walks up to your hand and presses one side of its face against your fingers. The head may turn slightly as the cheek slides along your knuckles. A few seconds later, the same cat might rub against the corner of a chair, the edge of a doorway, or the side of a laptop. These movements feel affectionate because they often happen during calm social contact. They also have a physical effect that is easy to miss. The cat's skin produces oily secretions that can be transferred onto whatever the body touches. Sebaceous glands are part of this process. These are glands connected with the skin that release oily material called sebum. In cats, scent-producing glands and sebaceous tissue are especially important around areas such as the lips, chin, cheeks, forehead, and the base of the tail. When the cheek presses against a table leg or a person's hand, tiny amounts of this material can move onto the surface. The transfer is far too small to leave a visible stain under normal conditions. Chemically, though, the surface has changed. The same thing happens when a cat repeatedly returns to one corner of the sofa. A single rub may leave only a faint trace. Daily rubbing over weeks creates repeated layers of contact in the same place. That helps explain why some cats seem to have favorite rubbing points around the house. A doorway at cat head height can become especially familiar because it is passed again and again. Chair legs, bed frames, cabinet corners, and human ankles can all receive the same treatment. Cats also rub directly against one another. When two familiar cats press their heads or bodies together and slide past each other, the behavior is often called allorubbing. The prefix allo means other, so the word describes rubbing directed toward another individual. It is commonly seen between cats that have a friendly or familiar social relationship. One cat may begin by touching its forehead or cheek to the other. The contact can continue along the neck or side of the body before the animals separate. Physical contact transfers odor in both directions. Over many interactions, cats sharing a home can carry overlapping chemical traces from themselves, each other, common sleeping places, and the humans they regularly touch. This is part of why scent communication in cats is more complicated than the popular idea of marking something as property. A cheek rub does not need to mean, "This belongs to me." The same rubbing behavior appears in friendly social situations where territorial conflict is absent. It can help maintain familiarity between individuals and with frequently used parts of the environment. Context matters. Urine marking provides a useful comparison. A cat spraying urine onto a vertical surface is performing a very different behavior from quietly pressing its cheek against the corner of a chair. Urine carries powerful chemical information and can be involved in territorial or reproductive communication. Facial rubbing is usually calmer, closer, and tied to repeated contact with familiar places or individuals. Treating both behaviors as the same kind of territorial claim would erase an important difference in how cats use scent. For a cat living indoors, these small deposits accumulate through ordinary daily movement. The human adds skin oils and body odor to a pillow. The cat sleeps there and adds fur, skin secretions, and its own scent. Later, the same cat rubs along the bed frame before walking out of the room. The environment keeps changing in tiny amounts. That makes the chemical landscape of a home partly shared. People create some of it through touch, clothing, bedding, and movement. Cats add their own traces through rubbing, resting, and repeated contact with the same surfaces. A piece of clothing caught inside this exchange can become especially interesting. A sweatshirt worn close to your skin can already carry your chemical profile. If your cat rubs its face against the sleeve, kneads the fabric, and sleeps there repeatedly, the garment begins collecting traces from both sides of the relationship. That exchange becomes easier to picture if you follow one hoodie through an ordinary day. You wear it for several hours while moving around the house. The inside of the collar touches your neck. The sleeves brush your wrists and forearms. Warm fabric rests against your back and shoulders, collecting small amounts of skin oil, sweat, hair, and the odor compounds produced by bacteria living naturally on your skin. Later, you take the hoodie off and leave it on the bed. A few minutes pass before your cat walks over. Its first contact may be with the face. The cheek presses against one sleeve, transferring a small amount of oily material from glands around the head. A paw steps onto the fabric. If the cat begins kneading, its front feet press down one after the other, moving the cloth beneath them and bringing fur, paw contact, and tiny amounts of skin material into the same surface. Then the cat turns in a circle and lies down. For the next hour, much of its chest, side, belly, or back may remain pressed directly against the garment. Loose hairs collect between the fibers. Warmth changes how easily some odor molecules enter the air. Pressure spreads existing oils through the cloth. By the time the cat gets up, the hoodie carries a slightly different chemical mixture than it did when you first dropped it there. Later, you pick it up again. Some feline hair comes away on your hands. The garment may be worn another time before it reaches the laundry basket. That second period of wear adds more of your own material while redistributing traces already held by the fabric. This cycle can happen again and again with a favorite sweatshirt, pair of pajamas, or blanket. Textiles are well suited to this kind of repeated exchange because their fibers create a large surface area. Cotton is made from twisted cellulose fibers. Polyester is built from synthetic polymer fibers. Fleece fabrics contain many fine strands designed to hold air, and those same complicated surfaces provide many places where oils and odor molecules can remain until they are washed away or gradually released. Washing changes the mixture substantially. Detergent helps remove oils and other residues. Warm water and movement loosen material trapped among the fibers. Drying carries away moisture and some volatile compounds. A clean garment then begins accumulating new traces as soon as it is worn and handled again. Over weeks or months, a frequently used piece of clothing can pass through this cycle many times. That repeated contact helps explain why an old sweatshirt may receive immediate attention, while a brand new cat bed is treated with suspicion. A bed fresh from a store may smell of synthetic fabric, foam, plastic packaging, cardboard, a warehouse, or the manufacturing process that produced it. Even if the bed feels soft and looks inviting to a human, its chemical profile can be completely unfamiliar. The old hoodie has a history the cat has already encountered. Its exact odor changes after every wash and every wear, yet enough familiar features may keep returning for the object to remain recognizable within the home. The cat may also help refresh that familiarity through its own repeated contact. This does not require the cat to understand the garment as a symbol of the relationship. There is no need to imagine a deliberate plan to combine two scents into one. The process can happen automatically through normal behavior. You wear the clothing. The cat touches it and rests on it. Fabric preserves some of what both bodies leave behind. Repeated exposure then makes the object increasingly familiar. That familiarity can become especially strong when the same garment appears in the same bedroom, on the same chair, or near the same person over many months. Chemical history gives the clothing one reason to attract the cat. It still cannot explain why the cat stays there long after the sniffing is finished. A cat that curls up and remains asleep for an hour is making a resting choice, and resting places have to satisfy needs that scent alone cannot provide. Once the first few minutes of investigation are over, the cat is making a different kind of choice. Sniffing gathers information. Settling down commits the body to staying there. That matters because rest changes how quickly an animal can react to what is happening around it. A cat standing with its head raised can turn toward a sound almost immediately. During quiet rest, the muscles begin to relax and the eyes may close, although the animal can still wake quickly. Deeper sleep reduces that readiness further. Domestic cats move through several states across the day, including alert wakefulness, quiet resting, lighter sleep, and deeper sleep. Those states do not all offer the same level of awareness. A lightly resting cat may respond to footsteps in the hallway with an ear movement or a brief opening of the eyes. During deeper sleep, the body becomes less prepared for an immediate response. That difference helps explain why resting places are selected with more care than a surface used for a few seconds of sniffing. A place that holds the cat for an hour has to work physically. Temperature becomes part of that decision. The surface under the body can either pull heat away quickly or help retain it. A cool tile floor behaves very differently from a thick sweatshirt folded into several layers. Cushioning matters too. Hard surfaces place more pressure on the chest, hips, elbows, and other contact points. Soft fabric can spread that pressure over a wider area and change shape beneath the body. Exposure is another part of the choice. A cat resting in the middle of an open floor has clear visibility, but its body is also exposed from every direction. A pile of clothes beside a pillow can form a shallow hollow with fabric rising around the sides. A laundry basket may add solid walls around the same soft material. The location of the resting site matters as much as the material itself. Some cats prefer higher places where they can watch a room from above. Others use enclosed spaces under furniture or inside boxes. Many choose socially close locations, such as the end of a bed, the back of a couch, or a chair beside the person they know well. The same cat can use several of these strategies during one day. A sunny windowsill may be attractive in the morning because it is warm. Later, a cat may sleep under the bed when the house becomes noisy. At night, that same animal may settle beside a familiar person. Resting preference changes with temperature, activity in the home, time of day, and what other resting sites are available. This is why there is no single perfect cat bed. A padded bed in a quiet corner may be ideal in one situation and ignored in another. A folded sweater may become more attractive because it happens to be warm, elevated, familiar, and close to the owner at the same time. Disturbance also shapes these choices. Cats often return to places where they have previously been able to sleep without being moved, stepped around, or startled. A chair that remains empty for most of the afternoon can become valuable for that reason. Clothing left there adds softness and familiar odor to an already predictable place. Repeated success can strengthen the preference. The cat settles there once and sleeps undisturbed. Later, the same place is available again. Over time, the location becomes part of the cat's regular resting pattern. Seen from this angle, a pile of clothes begins to function less like an interesting smelling object and more like temporary furniture. Its shape can support the body. Its layers can change heat loss. Its position can reduce disturbance or place the cat close to a familiar person. The smell may help attract the cat or make the site recognizable, while the physical properties help explain why the animal remains there after the investigation ends. That distinction is especially useful with laundry piles. A shirt spread flat across the floor offers one kind of surface. Several sweatshirts and towels stacked loosely together create something very different. They compress, form edges, and produce small hollows under the cat's weight. Once clothing begins behaving like a bed, the strange choice starts to make much more mechanical sense. The difference becomes obvious when you compare a bare hardwood floor with a heap of sweatshirts. Wood barely changes shape beneath a cat. A pile of clothing does. As the cat lowers its body, the fabric compresses under the chest, shoulders, abdomen, pelvis, and paws. Those contact points carry much of the animal's weight while it rests. On a rigid surface, that weight is supported by a smaller area. Soft fabric spreads the pressure over a wider patch because the material bends and sinks beneath the body. That is part of what makes a thick blanket feel more comfortable to us than a wooden bench. A cat experiences the same basic physics. The effect becomes stronger when several garments are piled together. A single thin dress shirt offers very little depth. 3 sweatshirts loosely stacked on a bed can create several centimeters of soft material beneath the cat once the folds overlap. Bath towels can do something similar. Fleece hoodies and knitted sweaters usually hold more loft than thin cotton shirts. Loft is simply the thickness created when fibers and folds hold open space between them. The more loft a pile has, the more room it has to compress beneath body weight. This allows the surface to change shape around the cat. A shoulder may sink into one fold while the pelvis settles into another. The sternum, which is the long bone running along the center of the chest, can rest against fabric that gives slightly instead of pressing against a hard plane. The abdomen may be supported by a loose ridge of cloth. Even the front paws can disappear into a shallow dip between 2 garments. These little changes can make the whole resting position more stable. Laundry piles also create shapes that flat surfaces rarely provide. A sweatshirt sleeve can form a raised edge. A folded pair of jeans may make a low ridge. Several garments tossed together often leave a shallow depression in the middle after the cat steps onto them. Once the animal circles and lowers itself, that depression may become roughly body-sized. The cat has effectively pressed the pile into a custom resting shape. This matters especially when the cat curls. A curled posture brings the head closer to the chest and draws the legs inward. The spine forms a loose arc. If fabric rises along one side, the cat can lean part of its body against that support, rather than holding every position entirely through muscle tension. The result resembles the raised edge of many commercial pet beds. Laundry simply creates the same kind of support by accident. A hoodie with a thick hood can make an especially useful boundary. The body settles beside the hood, while the folded fabric presses gently against the back or side. A pile of towels may create several low walls at once. Even a shirt left partly folded can produce one raised section that gives the cat something solid enough to lean into. This helps explain why cats often seem more interested in a messy pile than in the exact same clothes laid flat. The material has not changed. Its structure has. Several layers create more depth, more uneven support, and more space for the body to settle between folds. The pile also shifts slightly as the cat turns around before lying down. That movement allows the animal to reshape the surface with its own weight. By the time the cat finally tucks its paws underneath and lowers its chin, the clothes may fit its body better than they did 30 seconds earlier. From a human point of view, the pile may look untidy. From a mechanical point of view, it has many of the features built into a soft cat bed. It cushions pressure against the body. It molds itself around a curled posture. The folds can also create a raised edge that helps the cat stay settled once it relaxes. All of that happens before scent or attachment needs to explain anything further. The clothing has become useful simply because fabric behaves differently from a hard floor. Those same folds also hold many small pockets of air between the fibers and layers. Once a warm cat settles into them, that trapped air begins changing how quickly body heat escapes. A resting cat is continually producing heat. Its core body temperature usually stays close to 38 to 39 degrees Celsius. That is several degrees warmer than a typical human core temperature. As long as the cat is alive and metabolically active, heat moves outward from the warmer tissues toward the cooler environment. Some escapes into the surrounding air. Some leaves through contact with whatever surface is underneath the body. That direct transfer is called conduction. If a cat lies on cool tile, heat moves from the warm body into the colder floor, wherever the two surfaces touch. Wood and stone behave differently, but both provide a more direct path for heat loss than a thick layer of fabric. A pile of clothes interrupts that path. The effect comes partly from the fibers themselves, and partly from the air trapped between them. Air is a poor conductor of heat, compared with many solid materials. When small pockets of air become trapped inside fleece, between folds of a sweatshirt, or within a stack of towels, they slow the movement of heat away from the cat. This is the same basic reason insulation works in a winter coat. The useful part is the still air held inside the material. A single thin t-shirt creates only a modest barrier. Several loose layers can create much more. Fabric folds produce small spaces that hold air close to the body. The cat's weight compresses some of those spaces, while others remain around the chest, belly, legs, and sides. The result is a small insulated zone that warms gradually while the cat rests. A curled posture makes that zone even more effective. When the legs are drawn inward and the head comes closer to the chest, less body surface is exposed to the surrounding air than when the cat is stretched out at full length. The belly and paws become partly sheltered inside the curve of the body. If clothing rises around the sides as well, the cat loses heat more slowly from several directions. This does not mean cats are always trying to become as warm as possible. Their bodies still have to maintain a stable internal temperature. Animals spend energy producing and losing heat to keep that balance. Scientists use the term thermoneutral zone for a range of environmental conditions in which an animal can maintain body temperature without needing to spend much extra energy on heating itself or cooling itself. The exact comfortable range varies with age, coat, body size, health, activity, and the individual cat. A short-haired cat resting in a cool room may value insulation differently from a thick-coated cat lying in summer sunlight. Fresh laundry provides an especially obvious example. Clothes removed from a dryer may begin well above room temperature. A cat that climbs onto the pile immediately gets warmth from two sources at once. The fabric itself starts warm, and the layered material slows the loss of the cat's own body heat. The temperature of the laundry gradually drops, but the folds can continue providing insulation long after the obvious dryer warmth has faded. This may help explain the familiar race between a person folding clothes and a cat trying to occupy the warmest part of the basket. Room temperature laundry can still offer the same insulating structure. A sweatshirt left overnight on a chair has lost any heat it once carried from the owner's body. The fabric can still trap air when the cat lies down. A pile of towels can still reduce direct contact with a cooler surface. Warmth therefore remains one contributor even when the clothing does not feel warm to a human hand. The value also changes with the room. During a cool winter morning, a fleece hoodie may offer a stronger thermal advantage than it does during a hot afternoon. A sunlit windowsill may replace it for several hours. Later, after the sun moves away, the cat may return to fabric. Resting choices shift because the balance of heat, comfort, and location keeps changing through the day. That flexibility helps explain why clothes can become attractive under many different conditions. Their folds cushion the body while the trapped air slows heat loss. The cat effectively creates a warmer pocket simply by settling into the material. Yet cats also choose clothing piles that offer little thermal advantage at all. A cool laundry basket in a mild room can still become a favorite sleeping place. The walls, hollows, and edges around the body provide a different kind of benefit, one created by the shape of the space itself. A laundry pile changes again when it sits inside something with walls. The same towels that feel soft on an open bed can create a very different resting place when they are gathered inside a basket. As the cat steps in, the fabric shifts beneath its paws and settles toward the center. The sides of the basket remain fixed around the body. If the clothes are piled loosely, they may rise along the chest, hips, or back, while the container creates a clearer boundary around the whole resting space. That geometry matters. An open floor exposes the cat from every direction. A laundry basket blocks part of the view and creates a smaller area with defined edges. The cat can lower its body into the clothing while still keeping its head near the top of the basket, where sounds and movement in the room remain easy to monitor. A shallow plastic basket may only reach partway up the body. A deeper hamper can surround the cat much more completely. The amount of enclosure changes, but the basic effect is similar. The resting space becomes more contained. Piled clothing can create this effect even without a basket. A heap of sweatshirts on a chair may form a depression in the middle after the cat walks across it. Several folds rise around the sides. A pillow behind the pile adds another solid boundary. The back of the chair provides support from one direction. Together, these ordinary objects can turn a flat seat into a partly enclosed resting place. Suitcases often create an even stronger version. An open suitcase has firm walls, a rectangular floor, and one large opening above. If it is partly filled with clothes, the cat gets cushioning underneath with raised edges around the body. The inside dimensions of many carry-on suitcases are also close enough to a cat's body size that the animal can curl without leaving much empty space around itself. Cardboard boxes work through similar physical features. They provide clear edges and reduce visual exposure from several directions. Research with shelter cats has found that access to hiding boxes can help some animals adjust more quickly to stressful environments. In those studies, cats given enclosed hiding options sometimes showed lower behavioral stress scores during the first days after entering a shelter. That does not mean a laundry basket has been proven to calm cats in exactly the same way. The comparison simply shows why enclosure can matter biologically. A place with walls changes what the animal can see, how exposed the body feels, and how many directions need to be monitored. A cat inside a semi-enclosed space can remain partly concealed while still watching the entrance. That balance is useful for an animal that rests for many hours, but remains capable of waking quickly when something changes nearby. The structure also affects body support. A cat curled against the side of a basket can lean part of its weight into the wall. Loose clothing fills the gaps between the body and the container. If the pile forms a hollow, the cat may settle lower into the center, while the surrounding fabric rises along the flanks. The result can feel more stable than a completely flat surface. This helps separate two things that often appear together. Sometimes the clothes themselves are the main attraction. A cat may sleep on a sweatshirt spread across the bed with no container around it. In other cases, the surrounding structure adds much of the appeal. The same cat might ignore a folded shirt on a table, yet climb immediately into a laundry basket filled with similar fabric. A suitcase, basket, or deep chair gives the clothing a shape that a flat garment cannot create on its own. By this point, several influences can overlap in the same resting place. Familiar odor may help the cat recognize the object. Soft fabric changes pressure and heat loss. Enclosure changes visibility and body support. Those effects are easiest to separate when the clothing itself changes. A shirt worn for several hours and a basket of freshly washed laundry can feel similar under the pores, while carrying very different chemical information. A useful comparison appears in two scenes that many cat owners know well. In one, you take off a shirt after wearing it for several hours, place it on the bed, and your cat settles onto it almost immediately. In the other, you carry in a basket of freshly washed clothes, and the cat climbs onto the pile before you have finished folding anything. Both piles can feel soft under the body. Their chemical and thermal properties are quite different. A recently worn shirt has spent hours in direct contact with skin. Sebum from the neck, chest, arms, and back can transfer into the fibers. Sweat adds water, salts, and compounds that skin bacteria can later transform into recognizable odor molecules, hair, skin flakes, deodorant, shampoo, and whatever environments the person moved through during the day add further traces. If the garment has only just been removed, it may also retain some heat from the body. That combination makes recently worn clothing unusually rich in owner-associated information. Fresh laundry starts from a different condition. During washing, water and detergent remove much of the loose dirt, sweat, and oil that accumulated during wear. The clothes then emerge carrying far less of the recent body residue that was present before washing. If they come directly from a dryer, however, they gain a major advantage in another category. They are warm. The fibers are also often fluffed by tumbling, which increases the amount of air held between layers. A basket filled with warm towels or fleece clothing can therefore create a thick, insulated surface that compresses easily beneath a cat. A cat choosing fresh, drier laundry may be responding strongly to warmth and physical structure, even though the owner's recent body odor has been reduced. Air-dried clothing gives us a slightly different comparison. A shirt dried on a rack can be clean and soft without carrying the strong thermal advantage of clothes removed from a dryer. If a cat still chooses that pile, the appeal may involve texture, elevation, enclosure, familiar household odors, or learned habit. The arrangement matters as well. Freshly folded clothes often create neat stacks several layers high. A folded sweatshirt may produce a raised surface with thick edges. Towels can form a broad padded platform. A basket keeps all of those layers gathered closely together. The cat receives a resting surface that may be softer and more elevated than the bedspread or floor beside it. This is why the simple label of dirty laundry or clean laundry does not tell us which one a cat should prefer. Different cats can value different features. One cat may repeatedly seek out the shirt its owner wore that day. Another may appear only when warm towels come out of the dryer. A third may care most about the basket itself and climb inside whether the clothes are clean, worn, or somewhere in between. Those patterns can offer clues. A strong preference for recently worn garments makes owner-associated odor especially interesting. Immediate interest in hot dryer laundry gives temperature more weight. Repeated use of the same basket even when it is empty points toward shape, enclosure, and habit. These observations still cannot prove exactly what the cat is experiencing. Household situations rarely change only one variable at a time. A warm shirt may also smell familiar. Fresh laundry may be placed in a favorite location. A worn sweatshirt may form a better hollow than the clean shirts beside it. The causes remain intertwined. There is also no good basis for claiming that cats as a species universally prefer dirty clothes over clean ones. The more useful pattern is individual. Watching which clothing your own cat chooses and under what conditions can reveal which parts of the resting place seem to carry the most value. Washing makes that comparison especially revealing because it changes far more than cleanliness. The same shirt can leave the laundry room with much of its recent body residue reduced and an entirely new set of chemical compounds added by detergent, fabric treatments, water, and drying. Inside the washing machine, the chemical history carried by a worn shirt begins to change almost immediately. Water alone can remove some loose particles and water-soluble compounds. But body oils are harder to lift away because oil and water do not mix easily. Detergent solves much of that problem with molecules called surfactants. A surfactant has one end that interacts well with water and another end that is attracted to oily material. During the wash cycle, these molecules gather around skin oil, food residue, and other greasy material held on the fibers. Small clusters can form around the loosened oil, allowing it to remain suspended in the wash water instead of settling straight back onto the shirt. The water is then pumped away, carrying part of that chemical material with it. Mechanical movement helps too. As a washing machine drum turns, fabric repeatedly bends, folds, and rubs against other garments. Water moves through the spaces between threads. That motion helps detach material that has collected during hours or days of wear. A shirt that entered the machine carrying recent sweat compounds, sebum, shed skin material, and environmental residue can therefore emerge with much of that layer reduced. Reduced does not always mean completely erased. Some compounds bind strongly to particular fibers. Polyester, for example, tends to hold on to certain oily odor compounds more stubbornly than cotton, because polyester has a stronger chemical attraction to oils. This is one reason synthetic exercise clothing can sometimes retain body odor even after washing. Temperature, detergent type, wash length, and the amount of soil already in the fabric can all affect how much material remains. At the same time that washing removes compounds, laundry products can add new ones. A fragranced detergent contains volatile chemicals designed to produce recognizable scents, such as citrus, flowers, or so-called fresh linen. Some of those compounds remain on the fabric after rinsing. They gradually enter the air afterward, which is why a basket of clean clothing can smell strongly to a person standing several feet away. fabric softener can change the surface as well. Many softeners use positively charged compounds that attach to textile fibers. These coatings reduce friction between the fibers and make fabric feel smoother. Fragrance molecules may be included in the same product. Dryer sheets can deposit another thin layer of softening compounds while the clothes tumble in warm air. By the time a shirt leaves the laundry process, its chemical profile may contain detergent fragrance, residual softener, traces that survived washing, and compounds transferred from other clothes in the same load. Drying changes the mixture again. Water evaporates from the fabric and is carried away through the dryer vent or surrounding air. Some volatile odor molecules disappear with it. Heat can make certain compounds evaporate more quickly, while other substances remain bound to the fibers. A hot dryer also changes the immediate physical condition of the clothing by leaving it warm and full of air between loosened folds. To human eyes, it is still the same grey sweatshirt. From a chemical perspective, the version taken from the dryer is different from the one that went into the hamper. A cat may notice that difference before a person gives it much thought. Freshly washed bedding sometimes receives a long inspection when it is put back on the mattress. The cat may sniff along a pillowcase, paw at the blanket, or rub its face against fabric that had smelled familiar only a few hours earlier. Similar attention can happen with clean clothes placed on a chair. That reaction does not automatically mean the cat dislikes detergent fragrance. Individual cats respond differently, and many settle onto freshly washed laundry without hesitation. The more useful point is that cleaning temporarily changes a familiar sensory object. Some old chemical traces have been reduced. New compounds have appeared. Ordinary contact begins changing the fabric again, almost as soon as it returns to use. The first night on freshly washed sheets adds skin oils and hair. A cat sleeping at the foot of the bed adds its own traces. A sweatshirt worn the following morning begins rebuilding the body-associated odor that washing removed. Through repeated use, the garment moves back toward the familiar chemical environment of the household. Yet one part of its history continues even when its odor has been heavily altered. The shirt still appears in the same bedroom, near the same person, and often at remarkably predictable moments in the cat's daily routine. A cat does not need to understand laundry to learn what usually happens around it. Human clothing appears in repeated sequences every day. In the morning, a bedroom drawer opens. A shirt comes out. Shoes go on a few minutes later, and the person may leave through the same door at roughly the same part of the day. In the evening, that sequence often runs in reverse. Shoes come off near the entrance. Work clothes are changed. Jeans may land on the same chair, while pajamas appear shortly before the lights are lowered. To a cat living in the same home for months or years, these events provide patterns. Animals are good at learning patterns through repeated experience. One basic form is called classical conditioning. This happens when one event repeatedly predicts another. A familiar example comes from the work of Ivan Pavlov in the late 19th and early 20th centuries, when dogs learned that signals associated with feeding predicted the arrival of food. Cats can learn similar relationships between everyday household cues and what usually follows them. A person pulling on a particular jacket may regularly be followed by the front door opening. Changing into pajamas may be followed by quiet time on the bed. A bath towel appearing on the floor may predict that someone has just finished showering and will soon sit in the same room. The cat does not need a human concept of clothing for any of this to work. Repeated timing is enough. Another type of learning, called operant conditioning, works through consequences. If a behavior is followed by something the animal values, that behavior can become more likely to happen again. Suppose a cat jumps onto the bed whenever its owner changes clothes in the evening. Sometimes the cat receives a few minutes of gentle petting. Other nights, the owner settles nearby and the room becomes quiet. The cat may begin approaching the bed earlier because previous visits have repeatedly ended in a comfortable experience. Clothing can become part of that sequence simply because it appears at the same time. Stable routines also help animals estimate when events are likely to occur without reading a clock. A cat can use daylight, activity in the home, feeding patterns, sounds from appliances, and human movement as time-related cues. Clothes add another layer. The work shirt that appears before departure belongs to one sequence. The sweatshirt removed after coming home belongs to another. Pajamas can become closely linked with a quieter part of the evening. Over many repetitions, the objects themselves become associated with what tends to happen around them. Location strengthens the effect. Imagine that the same pair of jeans is dropped onto one chair almost every night. The chair already sits in a familiar room. It may remain unused for several hours after dinner. The jeans add softness, body odor, and a slightly raised surface. If the cat sleeps there successfully a few times, the whole arrangement becomes predictable. The following evening, the jeans appear again in almost exactly the same place. Predictability can be valuable because it reduces uncertainty. A cat entering the room has already experienced that chair when it was quiet. The clothing has already been investigated. The owner may be nearby performing the same familiar activities. Nothing about the situation requires much new assessment. This helps explain why some cats seem to appear almost immediately when certain clothes are set down. The garment may carry scent, but it also arrives inside a learned chain of events. A hoodie placed at the foot of the bed after dinner may signal a long stretch of low activity. Pajamas beside the pillow may appear when the bedroom becomes warm and still. A laundry basket set on the mattress every Sunday afternoon may reliably create a soft resting place for the next half hour. Over time, those repeated experiences can become as important as the physical properties of the fabric. The cat has learned when the opportunity appears, where it usually appears, and what tends to happen after choosing it. Once that pattern has been repeated enough times, one particular garment or resting spot can begin to stand out from all the others. Comfort experienced today can increase the chance of returning tomorrow, and repeated return begins turning an ordinary piece of clothing into a habit. Sometimes the preference narrows until one particular garment seems to matter more than all the others. It might be an old grey sweatshirt, a fleece jacket, or the same pair of pajama pants that keeps ending up on the bed. The first time the cat chooses it may be completely ordinary. The fabric is soft, the room is quiet, and nobody moves the cat for the next hour. That successful rest becomes part of the animal's experience with the object. If the same thing happens again a day or two later, the garment gains another layer of familiarity. Learning through reinforcement does not require a food treat or an obvious reward. A comfortable outcome can be enough. Warmth, a soft surface, protection from disturbance, or simply being close to a familiar person can all make a resting choice worth repeating. The basic process is simple. A behavior leads to a useful result. When similar conditions return, the animal becomes more likely to make that choice again. Suppose the sweatshirt is usually left on the same corner of the bed. The cat finds it there one evening and sleeps undisturbed. A few nights later, the sweatshirt appears in the same place. The texture feels familiar, the room is familiar, and the previous experience ended well. The cat settles there again. Repeated success gradually turns chance into preference. Scent can strengthen the pattern at the same time. Each resting session adds small amounts of the cat's own fur, skin oils, and gland secretions to the fabric. When the owner wears the sweatshirt again, fresh human odor is added back. The garment moves repeatedly between the two bodies. Washing reduces much of that chemical material, but the cycle begins again as soon as the sweatshirt returns to use. Over months, the cat can encounter the same object in slightly different chemical states, while still recognizing its broader familiarity. The location can become linked with the garment too. A sweater that always appears on one chair may become part of a larger learned resting pattern. The cat is responding to the combination of object, place, and previous outcome. Move the same sweater to the middle of a noisy hallway, and the preference may weaken. Leave it on the quiet bedroom chair, where the cat has slept safely many times before, and the entire arrangement becomes easier to choose. Familiar objects also need less investigation. A new blanket may receive several long sniffs before the cat decides what to do with it. A sweatshirt used for years has already been encountered in many contexts. Its smell changes from day to day, but the object itself, its texture, and its usual location have a long history behind them. The cat can often move more quickly from inspection into rest. This creates a feedback loop. The cat chooses the garment because it has been comfortable before. Sleeping there adds more feline scent and another successful experience. The owner later refreshes the human odor through wear, and the garment returns to the same familiar room. Each repetition makes the next choice a little easier. Nothing in this process requires the cat to think of the sweatshirt as a treasured symbol. Ordinary learning can produce a very strong-looking preference. What appears to us as a quirky attachment may simply be the accumulated result of dozens or hundreds of comfortable rests. Still, one feature separates your old sweatshirt from an equally soft blanket bought from a store. The garment is repeatedly connected with a living social partner. For many domestic cats, that person is more than part of the furniture or the daily routine. Research on cat behavior shows that familiar humans can become attachment figures, which gives the clothing associated with them an added layer of significance. That long history with one person can shape more than familiarity with a room, a chair, or a favorite sweatshirt. For many cats, the person themselves becomes part of how the animal judges whether a situation feels safe enough to relax. Researchers describe part of this relationship with the idea of a secure base. A secure base is a familiar individual whose presence helps an animal explore an unfamiliar place and recover after stress. The concept was first developed in research on human infants and later adapted carefully for other species. In 2019, Kristin Vitale and her colleagues tested whether domestic cats showed attachment patterns toward their caregivers. The researchers used a modified version of the secure base test. The setup was deliberately simple. A cat entered an unfamiliar room with its caregiver. For roughly 2 minutes, the person remained in the room while the cat could move around and explore. The caregiver then left for about 2 minutes. After that short separation, the person returned for another 2-minute reunion. Researchers paid close attention to what happened when the caregiver came back. A securely attached animal tends to show some contact seeking after separation, then settles enough to resume exploring or resting. The familiar person appears to help regulate the response to the unfamiliar situation. Other cats behave differently. Some remain strongly focused on the caregiver after reunion and have difficulty returning to exploration. Others show more avoidance or mixed patterns of approach and withdrawal. These responses were grouped into secure and insecure attachment categories. Among kittens whose behavior could be classified, about 64.3% showed a secure attachment pattern. The remaining cats showed insecure patterns. When the researchers tested adult cats, the proportion was strikingly similar. About 65.8% of the classifiable adults were placed in the secure category. That similarity mattered because it suggested the pattern was not limited to young kittens still developing socially. Adult cats living in established homes could also use a familiar human as a social reference point. The secure cats did something especially useful for understanding everyday behavior. After the caregiver returned, they tended to reduce their signs of stress and divide their attention between the person and the surrounding room. They could reconnect briefly, then return to investigating the environment. That balance is important. A secure base does not mean the cat must stay pressed against the person at all times. The relationship can support enough confidence for the animal to move away again. This fits well with the way many cats behave at home. A cat may spend part of the evening on the opposite side of the room, then come closer when something changes. It may sleep near the owner without needing constant touch. In an unfamiliar place, the same person can become more important because the rest of the environment offers fewer known cues. Attachment research also helps explain why owner-associated clothing can carry more significance than a random blanket. The garment has repeatedly been connected with someone whose presence may influence how the cat behaves. That gives the clothing a social history beyond its texture and warmth. Still, attachment by itself does not prove why a cat chooses a hoodie. The shirt may be soft, its position may be convenient, and previous rests may have strengthened the habit. Owner scent can add another familiar layer to those physical advantages. The attachment findings simply tell us that the person linked with that scent can genuinely matter to the cat in measurable ways. That makes the earlier scent experiment much more revealing. A familiar human can help regulate behavior in an unfamiliar setting, yet an object carrying that human's odor does not reproduce the full effect. The relationship depends on more than the chemical trace left behind on fabric. A living person provides a stream of changing signals that a shirt can only preserve in fragments. What remains on the fabric is only one part of the information your cat normally receives from you. When you are physically present, several sensory systems are working at the same time. Your cat hears the particular pitch, rhythm, and timing of your voice. It sees the way you walk across a room, reach toward a cupboard, sit down on the couch, or turn your head after hearing a sound. Your body gives off heat. Hands provide pressure and movement during petting. Even small changes in posture can tell the cat whether you're approaching, leaving, settling down, or paying attention. Many of these signals can become individually familiar. Studies of domestic cats have shown that they can distinguish their owner's voice from unfamiliar human voices. Recognition may appear through subtle behavior, such as turning the ears or head toward the sound. The response does not need to be dramatic for the nervous system to register the difference. Vision adds another source of information. The shape of a moving person changes continuously as they walk, bend down, sit, or reach toward the cat. Distance changes too. A person standing across the room produces a very different social situation from the same person sitting 20 centimeters away on the edge of the bed. Touch adds information that clothing lying by itself cannot provide. A hand resting against the cat's side has warmth and pressure. When the cat shifts position, the hand may move with it. If the cat leans forward, the person can respond by scratching under the chin. When the animal steps away, that contact stops. This constant adjustment creates feedback. Feedback simply means that one individual's behavior changes what the other does next. A living social interaction is filled with it. The cat approaches. The person reaches down. The cat rubs against the hand and the person changes the direction of the touch. The entire exchange unfolds second by second. A shirt cannot do that. It stays where it was left. Its temperature gradually moves toward room temperature. The odor molecules held in its fibers slowly disperse, while the garment provides no changing response to the cat's behavior. This difference helps explain the result from the experiment involving 42 adult cats and owner scent. The cats received familiar chemical information from an object carrying their owner's odor. That odor was real and recognizable. The object still did not reproduce the reduction in stress-related behavior seen when the actual owner was present. The cat's nervous system normally experiences the caregiver as a combination of smell, sound, movement, touch, and learned interaction. Those channels reinforce one another. Hearing a familiar voice while seeing the familiar person gives stronger context than either cue provides alone. Touch can confirm that the person is physically close. A response to the cat's own movement adds another layer. Over months or years, these signals become linked through repeated experience. A garment preserves only fragments of that larger pattern. Smell is the most obvious fragment because it can remain after the person leaves. A little body heat may persist for a short time if the shirt was just removed. The shape of the clothing may also be visually familiar. The interactive parts disappear as soon as the person is gone. That does not make the garment meaningless. Association can still give it value. A hoodie can carry odor from someone important, appear in a familiar place, and have a long history of comfortable contact. The cat may recognize it quickly and choose to rest there without the fabric needing to perform the full social role of the person who wore it. This makes the relationship between cats and clothing easier to describe with precision. The shirt can function as a familiar cue linked with a caregiver. It may contribute to recognition and help make a resting site feel known. Its softness and warmth can add physical reasons to stay. The living person remains a much richer source of social information. That difference also changes how we interpret one of the most common explanations for rubbing and sleeping on personal belongings. When a cat presses its face into your sweater or curls across your jeans, the behavior is sometimes described as an attempt to claim you. The scent biology behind that behavior is real, but ownership is a much stronger conclusion than the evidence supports. The phrase "your cat is marking you as theirs" appears often when people talk about feline rubbing. It is easy to see why. A cat presses its cheek against your hand, rubs along your leg, then curls up on the sweatshirt you wore earlier. Something physical really is being transferred during those contacts. The cat has sebaceous glands around areas, including the lips, chin, cheeks, forehead, and base of the tail. These glands release oily material onto the skin and fur. When the side of the face moves across a sleeve, chair leg, or human ankle, tiny amounts of that material can remain on the surface. Researchers can describe that transfer directly. The idea of ownership comes later, because it assigns a motive to the behavior. Cats use scent in several different social situations, so the surrounding context matters. Consider two cats that have lived peacefully together for years. One approaches the other, touches its forehead against the other cat's cheek, and continues rubbing along the side of the head. The second cat may return the contact. This kind of social rubbing is often called allorubbing. It occurs most often between familiar cats with an established social relationship. During the contact, odor can move between their coats. Neither animal needs to be defending territory for this exchange to happen. The behavior can appear during calm greetings or while the cats are resting near each other. Domestic cats also direct similar rubbing toward familiar people. A cat returning from another room may walk straight toward its owner and push the forehead into a hand. Some cats rub repeatedly against a person's lower legs after that person comes home. Others press their cheeks into fingers during petting. These interactions combine physical contact with scent transfer, and they often occur in relaxed social settings. Territorial scent communication has a different appearance in other contexts. Urine spraying is one clear example. A spraying cat usually backs toward a vertical surface, raises the tail, and releases a small amount of urine backward. Urine contains chemical information that can persist after the cat has moved away. This behavior may increase during territorial tension, reproductive activity, or changes involving other cats. Facial rubbing is physically different and commonly appears during friendly contact. Grouping every scent-related behavior under one idea of territorial ownership removes those useful distinctions. The same caution applies to dominance. Dominance can describe patterns in which one animal consistently gains priority over another, in particular competitive situations. It does not provide a general explanation for every interaction between a cat and a human. A cat sleeping on your jeans has not demonstrated social rank over you. A cheek rub against your sweater does not establish that the cat believes the garment, or the person wearing it, has become its possession. A more useful explanation stays closer to what the behavior actually shows. The cat interacts repeatedly with familiar individuals and familiar surfaces. Physical contact alters the odor carried by those surfaces. Those altered smells then become part of the chemical background the cat encounters again later. Your clothing fits easily into that process because it moves between your body and the places your cat already uses. A sweatshirt may begin the evening carrying fresh human odor. The cat rubs against it and later sleeps there. Some feline scent is added through face, fur, and prolonged body contact. The garment is worn again another day and picks up more material from the owner. Over time, both bodies contribute to the chemical history of the same object. Calling that process claiming makes it sound like a simple statement of possession. The biology points toward a broader role involving recognition, familiarity, and social contact. That explanation also leaves room for an important fact about cats themselves. Two cats living with the same person can react very differently to the same pile of clothes. One may seek it out every evening, while the other walks past without stopping. The value of scent, warmth, enclosure, previous experience, and closeness to a person can vary greatly from one individual to another. Two cats can live in the same house, sleep in the same rooms, and have access to the same pile of laundry while treating it very differently. One may climb onto warm clothes almost every evening. The other may walk past them and choose the top of a cat tree instead. That difference is exactly what we would expect from a behavior shaped by several influences at once. Age can change what a resting place offers. Kittens often sleep for long stretches because growth and development require large amounts of energy. Healthy adult cats usually divide their rest among several locations during the day. Senior cats may spend more time resting overall, while stiffness or reduced mobility can make certain surfaces easier to use than others. A deep laundry basket may be inviting to a young cat that jumps into it easily. An older cat may prefer clothing left on a low bed, where entry requires very little effort. Temperature can shift the balance too. A cat with a dense coat may lose heat differently from a short-haired cat. Body condition also affects insulation, because fat beneath the skin can slow heat loss. A lean, short-haired animal resting in a cool room may gain more from thick fleece than a heavily coated cat during warm weather. Even within the same individual, that preference can change between January and July. Social experience adds another layer. Cats differ greatly in how much contact they seek from people. Some regularly sleep beside a caregiver, follow that person between rooms, and approach quickly for physical contact. Others spend much more of the day resting alone, while still maintaining a familiar relationship with the household. Early experience can help shape those differences. Kittens exposed gently and repeatedly to people during the early socialization period are generally more likely to become comfortable with human handling and proximity later in life. Experience continues after kittenhood as well. Years of quiet, predictable interaction with one person can make closeness easier to choose. A cat that rarely seeks human contact may place less value on clothing strongly associated with a person. The available alternatives also matter enormously. Imagine a room containing a warm window ledge in direct sunlight, a heated cat bed, a tall cat tree, and a box lined with fleece. The sweatshirt on the floor now has serious competition. Move the same cat into a cooler bedroom with bare flooring and no other soft resting sites, and that sweatshirt may become much more attractive. Preference is always measured against what else is available. Height can influence the choice. Some cats repeatedly seek elevated shelves or the top platform of a cat tree, where they can watch activity below. Others use boxes, covered beds, or spaces beneath furniture more often. A cat that strongly values elevation may ignore clothing on the floor and immediately choose the same clothing if it is placed on a dresser or bed. Household composition can change the value of a resting site as well. In a home with several cats, access to favorite places may depend on who is already occupying them. One cat may control the sunny window for much of the afternoon simply by getting there first and remaining there. Another may use the laundry basket because it offers a quiet alternative with less social competition. Patterns like these can make a clothing preference appear much stronger than it would in a one-cat home. Previous experience continues shaping the choice at every stage. A cat that has slept undisturbed on one sweater dozens of times has a long history of successful outcomes connected with that object. Another cat may have been moved every time it climbed into the laundry because someone needed to fold the clothes. Over time, those different consequences can push behavior in different directions. This variation is useful because it reminds us that there is no universal ranking of scent, warmth, softness, enclosure, and social closeness. Each cat weighs those features through its own body, history, and current environment. A stable preference can remain harmless for years. A cat that has always slept on clothes may simply have found a resting strategy that works well. A sudden change deserves more attention because the cat itself has stayed the same while something around it, or sometimes within its body, may have shifted. The most informative clue is often not where the cat sleeps, but whether that choice appeared unexpectedly after months or years of different behavior. A long-standing preference for your clothes usually tells a very different story from a behavior that appears suddenly. If a cat has slept on hoodies for years, the habit may simply reflect comfort, familiarity, and repetition. A cat that begins spending most of the day inside a laundry basket after months of sleeping elsewhere gives us a new piece of information. Something in the balance of available resting places may have changed. Temperature is one possibility. As autumn turns into winter, a room that felt comfortable in September may become several degrees cooler by December. A thick sweatshirt or pile of towels now offers more insulation than it did during warm weather. Heating systems can also create uneven temperatures within the same home. A bedroom near an exterior wall may cool faster overnight than a room closer to a furnace vent. The clothes have not changed, but their value as insulation has. Noise can shift the balance just as quickly. Imagine that the cat normally sleeps on a couch beside a window. Construction begins in the building next door. For several hours each morning, drills, footsteps, or moving equipment now reach that room. The cat may start using a laundry basket in a quieter bedroom instead. The basket provides soft material underneath and walls around part of the body, while the location itself offers more distance from the disturbance. Visitors can create similar changes. A guest may occupy the chair the cat normally uses. Children moving through the room can make a previously quiet sofa less predictable. A suitcase placed in the hallway may block a familiar path. The cat responds to the new arrangement by choosing another place where activity is easier to anticipate. Furniture changes can matter even when the household seems calm. A cat may have spent years sleeping on the back of one particular armchair because it provided height, warmth, and a clear view of the room. Remove that chair, and the cat loses all of those features at once. A pile of clothing on the bed may become the closest available substitute. The preference can therefore appear suddenly, even though the clothing itself has always been there. A new animal can alter resting patterns more dramatically. In a multi-cat home, favorite places are shared resources. A newly adopted cat may begin using the windowsill another cat preferred. A dog may start sleeping beside the couch. Even without open fighting, one animal can make another location less attractive simply by occupying it more often. A laundry basket inside a bedroom may then offer distance, enclosure, and predictability that the previous resting site no longer provides. This is where the shape of the basket can become especially useful. The cat can lower itself between the clothes and keep much of the body below the rim. Movement in the room becomes partly screened. The container has clear boundaries, and its odor remains familiar. When the rest of the environment becomes less predictable, a small enclosed space can gain value very quickly. Most changes like these are ordinary responses to changing conditions. A cat choosing your clothes more often during cold weather, after furniture is moved, or while guests are staying does not automatically suggest illness. The broader pattern matters. A sudden resting change becomes more important when it appears alongside other changes in behavior or physical condition. Reduced appetite deserves attention. So does a noticeable decline in grooming, difficulty jumping or walking, changes in litter box habits, or unusual withdrawal from people and animals the cat normally approaches. Those combinations can justify a veterinary check because pain, illness, or reduced mobility can also change which resting places feel usable. Sleeping on clothes by itself is usually a harmless behavior. The useful clue comes from comparing the cat with its own previous routine. If the preference has existed for years, it may simply be part of that individual cat's normal pattern. If it appears abruptly, the environment, the available resting options, or the cat's physical needs may have shifted. With those differences separated, the original scene becomes easier to understand. A hoodie on the bed can offer familiar scent, softness, warmth, a shaped resting surface, and a quiet place near someone important, all at the same time. By the time your cat settles onto that familiar hoodie, many different advantages have already gathered in the same small place. The fabric carries compounds left behind by your skin during wear. Sebum from oily skin glands can remain on the fibers, along with traces shaped by sweat, skin microbes, hair, and the products you use every day. Your cat has encountered parts of that chemical profile many times before. Experiments with domestic cats show that familiar human odor can be treated differently from the odor of a stranger. That recognition gives the clothing a social connection to one particular person. The garment also belongs to a larger smell landscape inside the home. The bed beneath it may already carry your odor and the cat's own scent. The nearby chair may have been rubbed against hundreds of times. Repeated contact leaves small amounts of feline oil and gland secretions on familiar surfaces. When your cat rubs its face against a sleeve or sleeps on the same sweatshirt again, the clothing collects another layer of that shared history. Then the physical properties begin to matter. A hoodie does not stay flat beneath a resting body. Its folds compress under the shoulders and chest. The fabric sinks beneath the hips and paws, spreading pressure across a larger area than a hard floor would. A sleeve can become a raised edge. The hood may form a shallow support against the cat's back. Several garments piled together can produce a depression that fits the curled body surprisingly well. The same folds also trap air. A domestic cat normally maintains a core body temperature around 38 to 39 degrees Celsius. Heat moves steadily from that warm body toward cooler surroundings. Fabric slows some of that loss because trapped air transfers heat poorly, compared with many solid surfaces. Fresh, drier laundry makes the effect especially obvious, while room temperature clothing can still provide useful insulation once the cat settles into it. A basket or suitcase adds another layer. Raised sides reduce exposure from several directions. Loose clothes fill the space around the body. The cat can rest partly enclosed while still keeping its head near the opening, where sounds and movement remain easy to monitor. Experience can strengthen the whole arrangement over time. A sweatshirt left on the same chair every evening becomes part of a predictable routine. If the cat has slept there comfortably many times before, returning requires very little new assessment. The texture is known. The location has a history of quiet rest. Repeated, successful sleep makes another visit more likely. The person linked with the garment can matter as well. Research on feline attachment has shown that many cats use familiar caregivers as secure social reference points. In the 2019 secure-based test work, roughly 2/3 of classifiable kittens and adult cats showed secure attachment patterns toward their caregivers. That relationship gives owner-associated clothing an added social connection. Still, the clothing carries only part of what the person provides. The experiment involving 42 adult cats showed that an object carrying owner odor did not reproduce the same reduction in stress-related behavior seen when the actual owner was present. A living person brings changing voice, movement, touch, warmth, and immediate response. Fabric preserves only fragments of that experience. This is why one simple explanation rarely fits every cat. For one animal, familiar human odor may carry more weight. Another may care more about insulation or enclosure. A third may have turned one old sweater into a favorite resting place mainly through years of repeated success. All of those routes can lead to the same quiet scene. A cat circles once, presses its paws into the folds, lowers its body, and closes its eyes. To us, the object may still look like laundry waiting to be put away. To the cat resting there, it can be a familiar chemical object, a shaped bed, a warm pocket, and part of a long history with the people and places that make up home.